Hi, I'm David. Today on 3D Make It, we're going to be talking about firmware, how to compile Marlin 2.0 using VsCode and PlatformIO. Let's go! So before we install firmware, specifically Marlin, onto our 3D printer controller, what is firmware? Well, firmware is a software that helps hardware communicate with other pieces of hardware. For example, your 3D print controller plugs in USB to your computer or a Raspberry Pi. There has to be some sort of language that interfaces those two together, some sort of protocol. Firmware bridges that gap. So when we're looking at 3D printers and firmware on our controllers, all of them come with some sort of firmware. Some of them use Marlin, some of them use a custom flavor of Marlin built by the manufacturer, some of them use something called SmoothieWare, there's Repetier, there is a ton of different firmwares out there. Clipper is another new one that's showing its head. It installs on a Raspberry Pi and uses it as the controller to send commands to the 3D printer instead of the Arduino in your printer. All 3D printers have firmware. The firmware governs the 3D printer. So if all of them already have it, why do we need to worry about updating it? Well, the most important reason to update your firmware is just safety. Some features like thermal runaway protection are off from the manufacturer, even though they're using versions of the firmware that could handle it. So in this video, I'm going to show you how to install VsCode, use PlatformIO, and get new firmware installed and configured for a 3D printer. We're going to use a CR10S as an example in this video, but remember, anything that can run Marlin firmware will work. Now, just because we're using a CR10S in this video doesn't mean it's not going to work for you. All of my printers use Marlin on the controllers, so I can update them as I want. The SKR 1.3, the newest kid and the hottest buzz on the block, uses Marlin. So this video is applicable to any printer you want to use Marlin firmware on. So to get started, the first thing we have to do is go download Marlin. We can get the newest copy from going to the marlinfw.org page, clicking the download button, scroll down, and then we're going to come into the Marlin 2.0 for this video, and we're going to use the 2.0 bug fix. So that will download from the Github, but just to note, to use PlatformIO and VsCode, you need something bigger than version 1.0. So if you're going to use 1.0, you need to use Arduino Studio and not PlatformIO, but anything that's 1.1 or higher, so we are using 2.0, we can use PlatformIO to code. So now that our download's complete, we're going to need one more piece. So we're going to click on the Install tab, and you can see here that to install Marlin 2.0 onto our controller, we're going to need to install it with PlatformIO. Now PlatformIO by itself is not runnable, so you'll need some sort of text editor or background platform to run it on. We're going to use VsCode, and we're going to use VsCode to use PlatformIO. Now PlatformIO is an IDE, Integrated Development Environment. So what does that mean? Well, an IDE not only gives you the text editor, but it lets you compile code. So from here, we have a whole suite that we can use to compile Marlin 1.19 and 2.0 as we're doing in this video. This takes the place of Arduino Studio, and you won't have to worry about installing that package. So we'll go over to the Visual Studio Code website. The website is code.visualstudio.com. Now, from here, we're just going to click download, and then we're going to download the Windows 10 version or whatever version matches your architecture. So you can see here that the Visual Studio Code installer downloads relatively quickly because most of it's online. It's important to note that VsCode is not the same thing as Visual Studio. Visual Studio is a full development package put out by Microsoft. So if you end up at anything other than Visual Studio Code, you've gone to the wrong spot. So come to code.visualstudio.com and hit download. So next, all we have to really do is run the Visual Studio Code setup. So I just click that from my window here and it will launch the installer. So the installer comes up. You have to accept the EULA, read it. I have. Always read the EULA. It's important. We can leave this as default. We can also leave this as default. I don't need anything really special here, but make sure add to path is checked off. Next, install, and away we go. So Visual Studio installed. I'll leave this launch Visual Studio when I click finish, and we'll open it up. So when Visual Studio opens, by default you don't have PlatformIO. So what you have to do is go to these side menus here. We're going to click extensions, and from here we can search PlatformIO. Now all we have to do here is click install. Give it a second and it will install PlatformIO. It's relatively painless and easy to do. Once it's installed, we're just going to have to do a reboot, but we can see that it installs all of our extensions with it, which is awesome. Another helpful thing is if you're not sure if PlatformIO is installing, just look down in the bottom left corner. You'll see the little wheel turning and that Platform IDE is installing. Upon completion, we are prompted to restart VsCode. So go ahead and close it and then click the start button, and then we can just launch it again. I'll just type in VsCode to launch it up. Alright, so VsCode is open again. And when it opens, we can see now that we get greeted with another welcome window, which is PIO Home, which is PlatformIO, and we have successfully installed the development environment. Now one more thing you might need is to install Git for Windows. So if we go into our Chrome here and we look for GitHub for Windows, and we'll just go installing Git, and we can grab the installer. So that's desktop.github.com. I'll download it. And then once it's downloaded, we'll just install that as well. You may not need it, but I've needed it on a few occasions, so it helps to have it installed. It just sits in the background usually and does nothing. So the installer will launch. We can create an account. We don't have to. We're just going to skip this step. And then we're going to continue. And I don't usually submit the periodic usage and finish. So that's it. It's installed. We're good to go. So one last step. We've downloaded the Marlin bug fix, but we have to extract it. So go down to your downloads folder or wherever you put it. Click extract all. And then in the wizard that opens up, just click extract. You don't need to show the extracted files when complete. We're not going to be using them in here, although we will look at them briefly in the video. So our extract completed. I'm going to open Marlin and go into the Marlin folder. I'm also going to go into the config folder right now. So the config folder, it was in 119, 118, and all other versions previous here. But we can go into Creality, and I'm going to grab 10s and copy all of these files. Once they're copied, I'm going to go back into the Marlin folder. But it's good to note that all these brands exist inside of Marlin and have examples that you can start from. So you don't have to start configuring from default. So once I'm in Marlin, the bug fix folder, I'm going to go in Marlin, the Marlin folder. So just so we're keeping score from downloads, that's Marlin, Marlin, Marlin. Inside of this Marlin folder, we have Marlin INO, which we've seen before. That's what we used to use in Arduino Studio. I have my config.h and I have config.advanced.h. So what I'm going to do is I'm going to right click, I'm going to paste those files I copied, I'll replace them. So just click replace. This overwrites what was there, and since we already have the zip, we have a backup in case something horrible goes wrong. But remember, if you don't have the zip still, keep a backup of those files before you paste over them. So just back into the Marlin bug fix folder here, we can see that there's a PlatformIO, and this is where it really starts to change for us. PlatformIO is going to give us some settings inside that file to configure when we open it in PlatformIO. We've made it. We have PlatformIO open. We've got our project extracted and we copied our example file in from the examples folder. So all I have to do is import my Arduino project. Now I'm going to scroll down and go to my user and downloads. So wherever you put that file, that's where we're going. And then I'm going to leave it there. Now I'm going to also select a board. But you can see here before I move on that I went just into the root of the Marlin bug fix. I didn't actually go into Marlin. I just set at the root. So it's important to remember. I'm going to drop this menu down and we're using an Arduino, and specifically the Arduino that the board comes with on the CR10S is the 2560. So we can go here and we can actually select the 2560 and then we're just going to grab import. So we have an import. It's awesome. It loads down the left side here and our project loads more information on the right when we pick files. So what I can do now is go into my Marlin folder and I can look at our configuration.h and we can see it's not much different than before. We have all of our same configurable options. The thing I love about VsCode though is the running map down the side, so I can actually see what's going on here on the right hand side and I can scroll up and down through functions and lines and get it configured quite quickly. So the one thing we want to make sure of is that our board is defined correctly, not only in the project, but in the configuration H. So if we go down, we can see that the default serial port is hashtag port 0, and we also have our baud rate at 115,200. Standard options for the CR10S. Now, if you have another kind of board, you're going to want to be careful. Just because sometimes the baud rates can differ and you can move them up and down. But we can see here that since we did copy the CR10S, my machine name on line 136 is CR10S and our board is the ramps, which is all correct. It's going to do good things for us. So if you were using another kind of board with your CR10S, you could come in here and edit this name and just plop the new board in. So for example, if I was coming in and I wanted to use an SKR board with most of this config, clearly we're going to have to change some of the things on an SKR board to match. So if we bounce into the source and then we go down into our core, that's where the boards files is moved to. So if you click in there, you can see that there's a list of boards. So if you were using an SKR, the fastest way is just going to do a control find, look for SKR, and then it gives you the board definition here. So it's important to note that when you're copying out those board files, you want to make sure you copy all the information you need. So if I go to configuration.h, you can see that it's boards underscore ramps underscore creality. So if I go back into my source, into the boards file, I need to copy this whole line in order to get that 1.3 big tree SKR out of there. I'm going to leave it for now because we're just using the default values for the CR10S. Now we're going to bounce back into the CR10S config H file and we just want to make sure of a few things. We talked about safety and being one of the biggest reasons you want to move forward in firmware. Well, this is Marlin 2.0, so this is as new as Marlin gets. So I'm going to type the word thermal in, and we're going to look for thermal runaway protection. So thermal runaway protection is on line 561, and we can see here that it's on. Define thermal runaway protection is not in the green brackets, so it means it's not commented out, which means it's enabled. And this is what's missing on a lot of printers. One thing that we can do though is we can kind of eliminate some things. So when thermal protection is on, we have a hot bed, we have a hot end, but the CR10S doesn't have a hot chamber. So what I can do is I can just come in and I can do 2 slashes of the forward variety and just comment that line out. So now when I compile it, it's not going to actually fire that line on, which is awesome. We'll save a little space. We can go down, we can start defining other things, but the biggest thing in the file to make sure for safety is the thermal runaway. You can go through and you can prevent cold extrusion, and this gets a lot of people on line 550. basically your printer won't extrude unless the extruder is hot. So if you want to make sure that you can extrude to do cold pulls at lower temperatures, you might want to set that down to 160, 165, because then your extruder will still run. You can hard code things. So it's always a good idea to get your PID settings hard coded into your firmware, because then you know what they are going forward and you don't have to look back. Even though you should tune them often and have them updated, having them in your firmware gives you a good reference point. So you can see here, even though that it says Ultimaker on our PID settings for our hot end, it's actually just defining the normal PID. So we have 22, 1.08, and 114. So that's going to be active once we flash our printer control board with this firmware. So one of the last gotchas I see often is due to heating and the hot end and the bed. So by default, your hot end temperature can only go to 250. So I always come in here, I change it to 300. The bed is usually 120, but I'll change it to 100. Now the reason for that is I have Micro Swiss all metal hot ends. So if I choose to print nylon or something more exotic that requires the higher temperature, I can go higher. But if you have the stock set up for an Ender 3, leave it at 250 and probably 80 for the bed, because you won't be printing anything that requires high temperatures on the nozzle, which really rules out PETG and nylon for the most part, and ABS. The other place is the heater min temp. This is the temperature that tells the printer to shut off if it's too cold. So if you're printing in a garage during the winter, it could actually drop like to 4 or 3 degrees in there. In Canada, it could be minus 40. I'm not saying turn your printer on at minus 40 in a garage. What I'm saying though is if you know your garage is typically at 4 degrees and your printer won't start, you can come in here and you can set this to be the correct temperature for you. I wouldn't go below 2 degrees. I would keep it at a really relatively close temperature to this 5, but you can go up and down. So now we got everything close. We haven't saved our file here, but we can. So if I hit file, I can hit save just like any other file on the planet, and my configuration.h will upload, and I don't need to worry about the white dot that was there to let me know it's not saved. Down on the left hand side, these are the buttons that make a difference. We can have a build, and we can have upload. So what build does is it takes what we have in our project. So right now we have config H open from our Marlin project. So we can see it's here and here. So if I hit build, it's going to build. So that's the checkbox down here. It's going to build the project, which means it's compiling everything for us. We don't really have to worry about running through any extra steps. There's no commands we have to know. So you can see here that it's processing, and it's actually processing for the 2560 board. And then after a few moments, it's going to say success. It took 14 seconds and it did succeed. And you can see here that checking the size of my board and everything going on down here, it gives me all of the configuration info as I go down. The one thing that I will mention though is I cheated. Before I hit build the first time for you right now, I hit it before. And it definitely was not 14 seconds. My first build took 147 seconds and it was crazy. I'm just kidding, it wasn't crazy. But the reason it did is because I had all those changes and the first build always takes longer. But you can see here, down here, since I didn't change anything, I left all the settings, I just hit build again. It just really built off the last copy, and so it only took 14 seconds. It also had the dependencies installed and downloaded that it needed, but make sure you have that GitHub, because it will run into problems when you're talking 32-bit boards. It'll complain a little bit. So since we just built it, we can come to the folder here, and you can see there's a file name here, firmware.elf. So if I actually open my File Explorer window, and then I go into the Marlin bug fix folder, so that's our main folder where the Marlin folder was before. So just to count again, it's downloads, Marlin bug fix, we're there. There's a .pio, and then we can see that it's .pio build, and then we have the mega, and then it gives us the firmware ELF file, and the firmware hex file. So for all those you keeping scores with my last videos here, We installed Firmware Updater on Octoprint, so now we can use the firmware we just generated from here in Octoprint, and I can actually fire that onto my printer without even being there. Pretty sweet, huh? So if I go in here and I go to my Octoprint instance, and then I come in and I log in with my super secret usernames and passwords. So if I come into my Octoprint instance here, I'm going to ignore a bunch of stuff and click later on things. We can go to the settings wrench and I can actually go down to that firmware updater. I've configured it. It knows what port my USB's on. I can click browse and I can actually go to that folder. So if I go into downloads and then I go and do Marlin bug fix, then remember it was PIO, build, and Mega 2560. If you forget that, it's right here. PIO, build, Mega 2560. Now, I can scroll down and see there's the firmware hex. We just saw it in the folder over here as well. There's the ELF and the hex. The hex, I can click open, and if I hit flash, it's gonna flash my firmware, and I won't be happy because I've already made custom firmware for my CR10S. But you could click flash from here and you don't even have to get off your chair. It's amazing. Octoprint is wonderful. So going back now, we have compiled firmware, we've edited firmware, and we've made some really simple changes to make it a little safer. We've done it, we've uploaded it in Octoprint. If we didn't want to use Octoprint, we could come in and we could plug our controller into the computer here, and then we could click this arrow. This arrow is upload, which means once you plug that USB in and you hit upload, it's going to look for the USB device you just plugged in and send the firmware to it. Remember, you need a bootloader to do any of this. So if you don't have a bootloader installed, you're going to have to get one installed. You'll need an Arduino. You can use a Raspberry Pi to do it, or you would need the little adapter that you can get off Amazon. I'll put links to all this down in the videos here, and you should be set. So firmware, not that hard. We used VsCode plus PlatformIO to modify, edit, and use the example configuration for Marlin and get it ready to be sent to our printer. We can use Octoprint as I demonstrated. After we hit that build button, we can upload it to the printer without getting out of our chair here. If you plug your printer into the computer, basically creating that direct connection to the controller, you can hit the upload button and it will flash right from PlatformIO. Remember, flashing firmware can cause damage to your printer, so don't unplug or power anything off until you see firmware flashing complete. Once the flash is complete, do an M502. This will load the hard-coded defaults from the firmware to the printer. Do an M500. This saves the settings into the EEPROM. This will make sure that the settings that you worked with are the ones that you're actually using on your printer. You guys have been awesome. Thanks for watching. I hope you learned a lot. Like, share, subscribe to see those new videos come out. Have a good one.